In this video, we're going to be comparing series and parallel circuits and get to know how the circuits work and how to find the missing components of the circuits. So objectives are get to know them, find out how to find resistance, both the total resistance and for individual resistors, and also how to find amperage, voltage, and voltage drop where appropriate. Okay, let's get started with series circuits. So we're going to be using these relationships between volts, amps, and resistance. And so you can use this circle to help you identify how to set up the equations, or I also wrote them out here. This is what a series circuit looks like. You have your power, your amperage here, and the resistance, they're in a line. You see resistor 1, resistor 2, resistor 3. So the little number as a subscript tells you how many resistors there are. And the thing about a series circuit is if the circuit's broken at any point, no current will flow at all. And so this is like the old school holiday lights where if one goes out, they all go out. This is what it was. It's a series circuit. So for a series circuit, here's some things to know. The amperage is always constant in a series circuit. That's the reason why if you break the circuit, it's gone. But the amperage through each of these resistors is constant. Also, you can find the total resistance. It's really easy for the whole circuit by adding up resistor 1, resistor 2, resistor 3, and so on. A series circuit is where we would find voltage drop. And to find the voltage drop, you find the amperage for the circuit, and you do that by taking the voltage, total voltage, divided by the total resistance. So voltage divided by total resistance, and you get I. Now you might say, well, how did you get the total voltage of the circuit? And that would be something given to you. And then you would go through and find the individual voltages across the resistors, if say the resistors were different amounts. So to do that, you could then use your amperage and the resistor 1, resistor 2, resistor 3 using these formulas. So we know the relationship voltage equals amperage times resistance. So now you're going to plug in the resistor that you want and that amperage that we determined earlier to find voltage 1, voltage 2, voltage 3. If all the resistors are the same, then the voltages will be the same, but if they're different, then they'll be different. And the total voltage is just adding up the voltage across those 3 resistors. So that's how a series circuit works. So one of the first things you're going to have to do when solving these problems is first figure out which kind of circuit you have, and then apply the appropriate formulas. Now let's look at our parallel circuits. So our parallel circuit's going to use the same formulas, we're just going to use them in a different way. So you notice that the top of the page looks the same formulas at the top, but the circuit is different. So in a parallel circuit, the power source is here, and then the voltage is the same anywhere in the circuit, but the resistors are not in a line, but the current is split to each of these 3 parts. So the voltage is the same anywhere in the circuit. We're going to have to figure out how to find the individual currents across those resistors this time. So that's a little bit different. Parallel circuits are by far more difficult to figure out, like individual resistance, than series circuits. So for a parallel circuit, you need to know that the total resistance is always less than the other resistances, and that there's an inverse relationship between the resistance and the current. That is, if the resistance is going up, then the current is going down, and vice versa. So there's a whole other video about finding total resistance in a parallel circuit and finding individual resistors in a parallel circuit that you can check out on the YouTube page or on this link later on. But in short, the total resistance is given by this formula, and this formula says that total resistance is 1 over R1 plus R2 plus R3 and however many resistors. So if you only have 2, you leave this part out, and if you have 5, you'd put 1 over R4 plus 1 over R5. Use this one if you're trying to find total resistance. If you know your total resistance, but you're trying to find an individual resistor, you would take this formula and take the reciprocal of both sides. So essentially you would get 1 over RT, that's reciprocal of this side. And if you take the reciprocal of this, you just end up with 1 over R1 plus 1 over R2 plus 1 over R3. So it's the same formula, we just flip them both sides over, and that allows us to move these, like if we needed to know R3, we can move R1 and R2 to the other side and solve for R3. And again, there's another video that goes into much more detail and examples on how to solve this. So if you can find out the total resistance, and you can find out the individual resistors, then you can solve for the individual currents. So if the voltage is the same across, which we said, then we can find the individual currents by finding voltage over R1, because we're using this formula right here. But voltage over R1 gives us the current 1, current 2, current 3. And then the total current is the voltage divided by the total resistance. The thing about parallel circuits is the thing that they sell now with holiday lights is that if one path is broken, the current will still flow to the other ones. It's like the backup system, which makes it handy. Not so handy for solving the math part of it, but handy when you're trying to light something. So that's the parallel circuit. So you're going to have an opportunity to identify which ones are series in a line in parallel, which means that you see them like looking like this, lined up that way. You're going to have an opportunity to go through and solve some problems using these formula and work on some of the problems that you might find on your task assignment sheets from the diesel class. And ask me if you have any questions. Good luck.